This is an introduction to DePHY. DePHY projects have been making waves as a groundbreaking innovation in the Web3 landscape, while DePHY is considered a vital infrastructure for Web3 to gain mainstream acceptance. We, the DePHY team, have been working on simplifying the process of DePHY project development and gathered a set of insights regarding it. After months of effort, we had made a verifiable solution based on Nostr, which allows low-latency messaging for devices connected to DePHY networks. Besides the off-chain messaging solution, DePHY facilitates the development of DePHY projects as well by addressing 1. Provision of verifiable on-chain DID service for DePHY devices, involving the recording of device-specific metadata such as serial numbers, SKU, owner details, authorities, and also verifiable traits of devices, for example, proof of location and proof of TEE. The DID service can also interactive with off-chain part of the infrastructure to provide more possibility on building products. 2. Ensuring traceability of significant operation records and vital device actions. 3. Provision of oracles and roll-up services for messages dispatched by DePHY devices. 4. Provision of sophisticated smart contracts that efficiently harness the functionalities of the above modules for DePHY projects to operate assets and build dApps. Here is a demo showing how the DID service works with smart outlets on DePHY. As the DePHY project, we create the product first. Then we add the trait contract to the product. The trait contract will be executed to verify features of devices when activating devices. Now we can mint the DID record with metadata like public keys, serial numbers once the device is manufactured in the factory, so the end user will be able to activate the device DID on chain. Now as a user, we buy the outlet from store and are ready to activate it on chain. The app will grab an activation code and a trait payload from the device via Bluetooth that can prove the device be trusted. The trait payload will be verified by the trait contract. In this demo, the trait payload is the proof of the device location calculated with GPS coordinate and Bluetooth neighbors. Once the trait is verified, the device can be activated with the code and be bound to the user, and the devices will send sensor data to the Nostr off-chain network. Let's check how an oracle works with them. While the data are distributed in the Nostr network, we can roll them up to EVM with chainlink function. We use chainlink function to validate signature and writing them in contract storages. Since chainlink functions doesn't support WebSocket to interact with a Nostr relay, the off-chain codes will request data from a proxy server running on Cloudflare Worker or any other Cloud Function services. The proxy server will dump messages from Nostr network and upload them to IPFS. Then the off-chain codes will verify them within chainlink functions sandbox JavaScript runtime. We also use chainlink automation to make the stack running automatically in the same contract. Then we create a simple indexer to process verified data from the contract and bring the leaderboard front-end up. In the leaderboard, devices are ranked by their average power factor value. You can find out your own device and share your result on Lens.